Okay, so let's try doing this lesson on rocks. Okay, on this picture it says, how would you describe these rocks? Basically what you're thinking about is if you were told to organize them or classify them, how would you tell the difference? What would you separate them by? Okay, the definition of a rock says a rock is one or more minerals packed together. That's the definition of a rock. All right, again, it's written right up in here in this top bullet. It says they're considered the building blocks of Earth, and we classify them in the bigger groups of igneous, sedimentary, and metamorphic, and that's probably about what you know as far as rocks go. Okay, here are some pictures of some famous rocks. This is the amazing rock of Saudi. See if when you come in, you can let me know why it appears to be floating. What do you think is going on? Okay, the rock cycle, we went over this in class, but if I were you, I would put this diagram in your notes. You should be able to label this if it were blank on your test. Okay. So igneous rocks says originally are hot magma, and once it comes out, it's considered lava. So magma's inside the volcano. Once oxygen hits it, it comes out, it is now lava. And igneous is the Latin word for fire. Okay, so igneous rocks are known as fire rocks. I just said this, magma's underground, lava's above ground. This is important because magma is going to form certain kinds of rocks, lava is going to form a different kind of rock. All right, so igneous rocks are classified according to their texture. More specifically, their cooling rate, if you wanted to be honest. So the texture refers to what it's made of, composition, the shape, the size, the arrangement of crystals, or if it even has crystals. All right, so your first type is called glassy. And even though we call it glassy, it doesn't always look glassy. So glassy, in this instance, does look like it. Obsidian does look like glass. You'll see this in class. But pumice is also considered glassy because it doesn't have any crystals. So pumice is also an example of glassy. It's spelled P-U-M-I-C-E. Okay, aphanitic is your next one. It is fine-grained. It has crystals, but you cannot see them with the naked eye. You're going to have to use a magnifying glass or a lens of some kind. Your example here is basalt. Another example would be rhyolite. You're going to want to add that into your notes. It's spelled R-H-Y-O-L-I-T-E. Okay, phaneritic is coarse. You can see all the particles. That's what coarse-grained means. The crystals are easily seen. And in this example, your crystals are the black specks. Crystals are not always light. This is actually granite, so you're going to want to write that down. Porphyritic. It's hard to think of examples for this. You might see one in class. Porphyritic means the word porphyry, this right here, ending in the Y, actually means large crystals. And really, a better description of porphyritic is that it has large crystals with little tiny crystals beside it. So in other words, the crystals are all different sizes. They're not just one size. That's what makes it porphyritic. All right, so here are examples of igneous rocks that you need to know. You have granite, basalt, obsidian, pumice. Rhyolite is another one. I know I said it. Scoria, spelled S-C-O-R-I-A. It's just like pumice, just a darker version of it. And you'll see all of them in class. All right, so igneous rocks are extrusive or intrusive. Your extrusive, where the lava means it came out of the Earth's surface. And then your intrusive, it gives you examples down here. Your intrusive, formed inside the Earth, they formed as magma. And it gives you an example of granite. So this is very important. The cooling rate determines the size of the crystals. The faster it cools, the smaller the crystals. Okay, so if we see giant crystals, we know it's taken a long time for it to cool. Alright, so let's get into sedimentary rocks. It's important to notice the layers. You can see the layers here. Try to think of each layer as a different time frame in history, because that's really what it is. Alright, so sedimentary rocks come from sediments of other rocks. Had to have been carried and set down by wind or water. There are other agents that move things. We'll learn that later. Over time, it gets cemented together. Okay, so how do scientists group them? How do they classify them? They are classified according to the origin of the material. So specifically, where did they come from? Here's one that's been smoothed out, and you can tell it's by water, just by the shape, that water has smoothed it out. Alright, so what specifically breaks down rocks? There's lots of different things. Wind, water, the sun, temperature, glaciers, earthquakes. There's lots of different things. Okay, so your first category is called plastic. It says it's made of fragments of existing rocks. These are your examples over here. Okay, so we have silt and clay, mud, shale, mudstone. These are the ones that you'll need to know. Conglomerate are like big rocks put together. Your sandstone is made of sand. Your shale is made of mud. Okay, so those are the three plastic that you'll need to know those. So there's the conglomerate. This is what it looks like. Okay, so just a bunch of big rocks stuck together. It's probably one of the ugliest rocks. Sandstone, very pretty, very common, especially in the southwest. It's made of sand. It's at least 50% sand. Shale is made from mud. We have a lot of shale in Virginia, and we'll go over why. And it breaks apart very easily. It's pretty weak. The second class of organic means it comes from something that was living. Your first example would be limestone, and there are two types of limestone. This one specifically forms in the ocean. It's made of the shells of once living animals. It's also made up of coral reefs that have been passed, but they're not alive anymore. Okay, and chalk is limestone. So chalk is an example of this type of limestone. Coal is another example. Okay, it says if you were a geologist, you run across shale in an area. So in Virginia, we have shale all through the mountains. What does that tell us about Virginia? This means at one point, the water, the coast, the water was here, and all of this was underwater. Okay, which is why we have limestone here, and the shale here shows at one point that was the coast. That's why it was muddy. Okay, chemical rocks are your last sedimentary class. This means that there had to be some kind of chemical reaction. Large amounts of minerals left behind as water evaporates. Inside the caves as the water drips down. So we have rock salt, which is your halite. We have gypsum. This type of limestone that forms the stalactites and stalagmites are another example. Okay, the steps in the making of sedimentary rocks, you should know them. First, it has to be weathered, which is breaking it down. Then it has to be moved, which is actually erosion. It says transportation, but this would be erosion. Deposition means setting it down, and then lithification is the cementation or the hardening of it. Okay, and here are some interesting, a lot of people will collect different sedimentary rocks. Geodes are commonly collected. It's important to know that fossils are almost always in sedimentary rock. We're not going to see it in igneous because they would have been burned up, and we're not going to see it in metamorphic because the pressure would destroy it. You can never say never. Once in a while you might find it there, but generally it's going to be in the sedimentary rock. And so here they are looking at the fossils found inside of this sedimentary rock. Right, so metamorphic, our last class. This is a rock formed through extreme heat and or Meta means form, and morph means change, so it changes its form. There are three ways that this happens. One is called contact metamorphism. So when a volcano erupts, it erupts outside and underground. Okay, so above and underground. And when it's underground, if we imagine that this red is this lava that has come through, we call that an intrusion. It's inside the ground. And this yellow rock, maybe it was shale. Now the blue areas that are touching this extremely hot lava, magma, are becoming slate. They've changed their form. Now it's slate. So shale has been turned into slate. Regional metamorphism is when two plates collide, and that extreme pressure is going to form mountains, and we would get metamorphic rock in that way. And the last one is hydrothermal. Hydro always means water, thermal always means heat. And when we say hot water, we mean like 1,000 degrees. So we have this opening in the ocean floor where magma is constantly pouring out, and as it pours out, it heats up the water, and as that water moves across the bottom of the ocean, it creates metamorphism. Alright, so there are two classes, foliated and non-foliated. Foliated either has layers, where you can see the layers that made it up, or it has cleavage. Okay, so you need to add that here, it doesn't say it. Foliated has layers, or it has cleavage. The ones that you need to know are slate, schist, and gneiss. Non-foliated means no cleavage and no bands. Your examples are marble, hard to see that, and quartzite. Alright, so it's important to know the parent and the daughter rock. So granite becomes gneiss, limestone becomes marble, shale becomes slate, sandstone becomes quartzite, basalt becomes schist. Okay, sand is made of quartz, so that's kind of easy to remember. Shale and slate both start with S, same number of letters. Like, just try to think of ways that will help you to remember what goes with what. There are some examples. There's slate, soapstone. Soapstone was talc, okay, and then it becomes soapstone. Marble. That's it. We're going to do a lot more in class, lots of hands-on. I'm going to give you a little classification chart that you can fill out that will help you to study a little bit easier. And the rocks that I tell you you must know in class, you have to know them by sight. You have to know their name, their class, their special properties, etc. All right? See you tomorrow.